So good morning. My name is Matti Okkonen. I work as a senior scientist in VTT. And as said, my topic today is to tell you about the future of machine vision. Thank you. And the idea and the motivation behind this is that I'm trying to demonstrate some of the potential of machine vision so that it perhaps might trigger some ideas and insights in your head that how could it be applied to forest industry. Before that, shortly something about us. I'm sure most of you know about VTT, but those who don't, in a nutshell, VTT is a government-owned research organization, and we have about 2,400 employees, and our turnover is roughly about 260 million euros. And our role in the Finnish society is sort of bridge the gap between the academia and the industry, and creating a business out of technology doing applied research. And the part of VTT where I come from is called the Optical Measurements team. And there we have about 25 people with a long history of working on creating optical instrumentation for demanding industrial applications. And the way we like to work is through agile prototype development, so that we choose a technology for the problem in hand and very quickly try to take it from the laboratory to the real world and see how it works there. And the technologies we use are mainly spectroscopy and of course machine vision. And we've been applying these for different fields for a long time now, for metal, steel, paper, mineral processing, pharmaceutical manufacturing, defense, intelligent traffic, and so on, and perhaps more in the forest industry in the future as well. Now let's get to the point. So here we have a basic layout of a machine vision system with its components. First we have, of course, the camera, and attached to some kind of optics, imaging lenses, perhaps filters. Then we have some kind of illumination units. And all of these are hooked to the brains of the system with a computer which have the software and the image processing libraries. Now on the analysis part, there's been lately wrong direction. In the analysis part, there's been lately a lot of buzz, especially in the areas like data analysis, artificial intelligence, machine learning, deep learning, big data. You know all of these buzzwords. But on the background, there's been also a lot of development on the imaging methods and optics as well, and maybe they have gained less attention. And VTT has been part of this progress. I'd like that to show you a few examples what we have been doing in this field. 3D imaging is a big part of machine vision now, and will be also continue to grow in the future. And there's a lot of technologies for different applications here, and we've been applying most of them in VTT and also creating technologies of our own and commercializing them. A couple of examples of that. Structured light is a 3D imaging technology where you project a certain pattern into the object you want to see, and from the distortion of the pattern you can get 3D information. An example in the top row, there's an example of microtopography measurement, where we achieve the height resolution in the scale of micrometer. And in the lower row, there's a concept for road quality measurement and mapping through taking 3D snaps of the road while driving and assessing the quality parameters from the 3D information. We've been applying photometric stereo for online particle size analysis for pharmaceutical manufacturing. And there we are using the 3D information to capture the accurate size and shapes of the particles and creating the size distribution while they're flying mid-air online. And we created the online prototypes, and finally it has been commercialized by an Irish company called Inferno Labs. We have a long history with Valmet, or Metso, and we've been part of also creating their product called IQ Surface Measurement. And the IQ surface captures the microtopography of the paper sheet while it's running in the mill with a speed of 120 kilometers per hour, taking snapshots with the height resolution less than 1 micrometer, and then it derives some quality parameters of the paper from the 3D information. One exciting technology we're looking at right now and doing research on is called the spat-tough 3D scanning. It's an exciting technology with a horrible name. Basically, it's a point-wise distance measurement where you can get an image or a point cloud by mechanical scanning. And the main point of this technology is that it can see through scattering media such as dust, smoke, windows, even tree branches. And the way it works, that for the single point, we shoot a very short laser pulse, and when it hits something, some of the photons will scatter around. And some of the scattered photons will come back to the detector, and the detector has a very accurate stopwatch there, and it's recording the time of the photons to come back. And so we get a signal of the amount of photons as a function of time. And from that, we can get the distance to all of the objects the laser encountered. And we're not getting just the first or the biggest object, as with the traditional time-of-flight imaging. We did one experiment in a lab. We scanned a tree nearby with the 14 meters of distance. And what we did is we hid a couple of cardboard boxes on the tree trunk behind the branches. And at the lower left, you can see the image from the scanner, and the boxes are not visible by eye there. But with this, we can sort of reveal that information behind the branches. Simple demonstration what it can do. So, very excited about this. We've been also doing research projects with European Space Agency for spaceborne landing. We did an underwater 3D scanner for the very hazy Arctic waters. And we've been looking at 3D information and still converted through smoke and fire. Some commercial examples of our 3D research is Focal Spec is one of our spin-off companies from our team that commercialized a 3D imaging technique called confocal line imaging. It captures the 3D surface of glossy sheet materials, taking accurate 3D profiles. Helme Imaging is also a spin-off from our team. It commercialized a technique called covered stereo dereflectometry, and it can capture the 3D shape of a freeform mirror object that was not possible before. Applications are in quality inspection. You heard about hyperspectral imaging. It's another type of novel imaging that creates new applications. And I think that the main contribution of VTT for this field is Fabry-Perot-based and microelectrical actuator-based tunable filter that essentially enables low-cost, small, portable hyperspectral cameras. And we've been done a lot of research in this area with different applications ranging from mobile to handheld to health and diagnostics, chemical detection, and even for space applications. There's actually a satellite flying around the globe right now with one of our equipment there, running for about a year now. Here's an example where we sort of combine machine vision with spectroscopy with the application of detecting ice on the windmill blades, which is a problem. And the idea is to come up with an inexpensive solution that could measure only a couple of wavelengths to detect the absorption range of the water and ice. And as you can see, we get a much more better contrast from the ice than in traditional RGB imaging. Here's another good example what hyperspectral imaging can do. It's a picture of a RGB image of a tablet, and if you take a look at it in different wavelength ranges, you can get this out of it. You can see the spatial sort of distribution of the active product ingredients in top of it, for example. So the difference is pretty clear. In addition to hyperspectral imaging and 3D imaging, we've been also creating new other types of imaging methods. One place we've been active is particle size imaging for application ranging from barley quality in beer making to bubble size in mine processing, mineral processing. And one thing exciting thing we're doing right now is assessing the quality of concrete continuously from manufacture to transport to casting to avoid problems like you heard, like the hospital in Turku or the bridge in Kemijärvi or these sorts of things. So this is one current topic in this. Another example, Enkema is a customer, and together we're now creating an imaging system that could simultaneously capture images of small objects with high spatial resolution and extended depth of field where traditional optics fail. And we do it so that we get an unconstrained view from any angle of that object without any occlusion or any mechanics on the image. And the idea and the application is to create a location-independent, accurate quality assessment tool for the gemstone industry. And we're hoping to commercialize this soon with them. Also, we've been doing optics for omnidirectional imaging, and the applications range from 3D scanners, 3D imaging to 3D stereo vision for environment perception for automatic vehicles. And quite lately we did also Omni optics for the thermal range. And the applications lies mostly on security here. Advocam is a spin-off company of VTT who has commercialized a new type of X-ray imaging sensor. And how it differs from the traditional X-ray is that first, it's an edgeless sensor. You can combine as many as you want to get a bigger area. And it can separate the energy channels of the X-ray source, so you can sort of get a color image and separate different materials. And maybe the main point is that it has no noise. So you can get ultra high contrast on light materials and small absorption differences, which was not possible before. I think the image of the cockroach is pretty nasty, but it demonstrates in a nice way how accurate you can get with this. Now we also invested a laboratory in VTT Oulu that we have all the equipment and the sensors to do application studies and feasibility studies, and we got the permission from Tukes quite recently. This was all about imaging, but we're also getting ourselves in the field of artificial intelligence. And here is just a simple demonstration what machine learning can do. There's a website with a demonstration of neural network that has been taught to recognize different materials in urban environment. And I just fed in a picture of Joensuu city center. And this is what we got out. And as you can see, it's doing a pretty good job. It's recognized the sky and the land and the buildings, even some poles and the pedestrians, car and a tree over there. And one ongoing project we're applying this is called X-Mine. It's a EU-funded big project. And there we are using the Advocam X-ray sensor, Röntgen fluorescence together with 3D, and using machine learning to separate the rocks in the mine based on their mineral content. And so this is ongoing. And I think this slide pretty much takes me to the end of the presentation, and I hope I was able to give you a glimpse what machine vision can do. And I think just a concluding statement is that, and the answer to the topic is that if we combine artificial intelligence and machine learning with the novel
Thank you
imaging
very
methods,
much,
I think
Matti.
it
So
creates
now
very
it's
interesting
time to
possibilities
questions.
in the
So
future for machine vision
who will
and for
make
the
the
forest
first question?
industry as well. All right, that was it. Thank you so much for listening.
Slava Nikov, Photonics Field. May I ask about VTT?
Sure.
So VTT is a national company which serves research and development needs
Exactly so.
and prototyping.
Yep.
So if, for instance, some company has an idea of the product that will be available for market and asked VTT to make a prototype of that product. So first question, how the issues of ownerships of the product are solving, and like further certification of that product, like if it's developed together with VTT, so and VTT has a like high reputation in worldwide, so how the issues of certification are held in?
Well, we have 3 types of projects: are self-funded, where we own all the results, of course. Then we have a co-funded project where you or some, like the case of Business Finland, comes in help. And then the ownership is mutual. And for the companies like Endgame, for example, the companies is paying all the bills, and they get all the results and ownership. So there are 3 types of projects related to the ownership. And we don't have an official VTT certificate, but I think that's a good idea to have.
Hi, I'm Nina Heiskog from Nordic Geocenter. Just wondering, you've kind of gone through the many fields, but where do you see personally, like there would be the biggest growth at the moment, or let's say in Finland or globally?
Well, as I said, Finland is a small country. When we come,
globally.
yeah, it's global.
But in which field?
That is an excellent question. I don't have a good answer at the moment. I'm very sorry. Forest industry.
There is a very nice, large variation, different type of machine vision methods. And now you put the hat so that you're thinking that what kind of application or solution could be the most interesting for this audience, so forest industry. So what is your point of view? So what kind of is a, how to say, high level or that kind of interesting method?
Well, I think I'm sure you heard about yesterday. I was not yesterday here, but about UAVs and drones, and for example, hyperspectral cameras. But from this, if I have to choose one, I'll choose with the 3D scanning technique with the awful name. And I think it will have a lot of application, and we already have sort of creating things around it for the forest industry. For example, I don't know the terms, but cutting down the trees with the device.
Please tell me a little bit more. Something application. So what could be the interesting application? What is possible to use that method what you are showing?
Well, if we can see through the branches, you could scan all the trees around and get their parameters, that's how curvy they are, what shape they are, and perhaps optimize the whole process of gathering the trees so that you're not so that the person operator doesn't have to make so many decisions. So there's like artificial intelligence combined with the 3D imaging, and they say, okay, cut this tree, but not this tree, and optimize it against some criteria, maybe for the growth of the forest or the price of the things, and so forth. That would be one application.
So how ready that is, or how ready it is? So it's possible to put in the machine. Already?
Yeah, as we demonstrated, I think from technology point of view, there's no limits. It's a question of creating the application and getting the cost and everything and the size to the range that it's applicable.
Okay.
So there's no big blocks on the way.
Okay.
Thanks. Alejandro Dominguez from Infotech. I was just I wanted to ask about this awful name technique, as you said. How deep can you measure? So you were showing results from a distance of 17 meters or something like that.
Yeah,
but we were seeing some imperfections in the determination of the shape of the cardboard boxes, so on. So.
Yeah, it's a question of how powerful laser we can use, and the detector can count individual photons. That's where the name comes from. So I think there's not a direct limit to it. It's a question of how powerful laser, and how it's about safety, I suppose. How long will we go?
Because when you were mentioning if you would apply this technology over a drone, then you certainly have a limit on the height of the drone can fly. So it will be, if you are I don't know, 50 meters away and you cannot measure to the ground level, that will be a problem.
I'm not a direct expert on this technique, but what I know, I assume that 50 meters could be possible. But if you have, I can provide you more detailed answer later.
Just a comment to you, because yesterday when I spoke about the scanning from drone, it's also a multiple return system, so detecting also like on a photon level. And you can return, basically measure several kilometers of distance. And yeah, currently I think it's a global development of using these single photon calculating systems, but I don't think the distance has a limit. I mean, it's a question of the accuracy of the range measurement that you are wanting to have, and if that's enough for your needs.
This may be a foolish question from someone a bit naive in this, but can you just explain what makes it machine vision versus simply optical vision or scanning? Does it mean something specific?
If you think about imaging and machine vision, I think that the point of machine vision is there's some kind of intelligence behind the images that take some kind of parameters out of the image. So the images themselves don't matter. So machine vision is basically combining imaging and this sort of artificial intelligence that can get the information out of that image. I hope I answered your question.